Hi everyone, and welcome to the 2017 Code Talk series. This series is co-sponsored by ODTUG and IOUG and provided by Oracle Developer Advocates. Today's webinar is Rapid Web Application Development in the Cloud, presented by Blaine Carter and Kris Bhanushali of Oracle Corporation. If you have any questions at any time during the webinar, please type them into the question box and they'll be addressed either during the webinar or during the Q&A period at the end of the presentation. Today's presentation will be recorded and will be available to everyone through the Code Talk page of the ODTUG website. So welcome Blaine and Kris, and thank you both for being here today.
Howdy.
Hey.
Thanks a lot. So I'll start out with telling you a little bit about myself. I'm Oracle's developer advocate for open source, and so what I do is I look for open source tools that can help out, Oracle developers do their job a little bit better. And I also try and find open source projects that might need a little help with the database, and then I can help out on that side. So I kind of work two different angles. And I'm here with Kris.
Hey everyone, I'm Kris Bhanushali. I'm a product manager for Oracle's cloud services, and I build the Oracle Cloud, work with our engineering teams, work with customers to understand the requirements, and overall help customers start using the Oracle Public Cloud.
And so one thing I've noticed in my I'm getting kind of old, you can see the gray there, in my long history of working with the Oracle database is in the past I've kind of felt like Oracle developers or just database developers in general were kind of left out of the new cool tools that all the other languages programmers got to use. And that's changing. So Kris, could you tell us a little bit about what Oracle's doing to enable developers?
Sure, fantastic question. And I do keep, I get asked this question a lot. First of all, I want to just explain how Oracle considers developers, and for Oracle, what are these developers? We have basically two categories of developers in Oracle land, right? There's within a customer base, the hardcore developers whose job is day in, day out. They build applications for their companies, write code, are deeply technical, and deal with all sorts of programming languages, Java, JavaScript, etc. So that's those developers. Oracle also has a other class of developers, which typically are part of the line of businesses. And while they are not into coding a whole lot, and they could be, but most of the times they have a line of business job. They could be in the finance department, marketing, developing, say, for example, BI application, creating reporting dashboards, or even extending the Oracle apps that they might be supporting. So that's that class of developers. And we have to make sure that we enable and provide tools for both of them. And so I'm just going to walk you through a few slides to kind of explain what we have and how we support both of these developers.
Okay, I'm gonna drop my face off the screen so you can have a little more for your slides.
So number one, of course, Oracle has one of the largest developer communities in the world, right? We support Java, we own Java, and Java is one of the most popular programming languages. So that's that. But on the newer stuff, as you mentioned, Blaine, JavaScript, for example, is becoming really popular in the front end and the back end. And we have our own JavaScript extension toolkit, the Oracle Jet, which customers use for faster development of web applications. And really, HTML, CSS, JavaScript skills are common, and it's wise to kind of be able to leverage that. And so we support that for the front end, especially for our the line of business customers, for example, who would like to build dashboards and reporting tools. We provide a lot of those widgets in our extension toolkit so that they can create really good looking dashboards and applications. And in the end, it empowers both the developers and the business users, for example, on the same infrastructure. So you're not having different types of codes and different ways of debugging it, and it just keeps everything simple. And not to mention, finally, that we use this framework ourselves for the Oracle Cloud Services. So when you log onto the Oracle Cloud and you see the UI, it's all based on Jet. Then on the back end, again, JavaScript is also getting very popular on the back end through Node.js, which, as you all know, is a JavaScript-based application server backend engine, and it's very popular for its asynchronous, event-driven architecture. And not to mention, of course, that it's open source. And so to support Node.js, number one, we provide a great driver, Node Oracle DB driver on NPM, which basically makes it really easy for the application to talk to the Oracle database. And so in our customer base, we find that, for Node.js applications, customers continue to use the Oracle database in the backend. And so it's a really easy way to deploy an application against an Oracle database. We also provide in our cloud a Docker-based container service. So deploying Node.js-based app servers becomes really easy. It's a matter of seconds, and you have an app server up and running. Now, on the other side, I mentioned the line of business users, and many of them, they don't want to code. They don't want to write too much code, but they still are responsible for building good-looking applications. And there are two important services that we provide for that. One is, of course, a service in the cloud called the Oracle Application Builder Cloud Service, whereby customers can use drag and drop and build really, good-looking applications quickly with basically no coding, and it's a visual development environment basically. So it's more for drag and drop kind of a service. And this is a full-fledged service, by the way, that's available in the Oracle Cloud. And all the tools, around it are built in. Rapidly connecting it to an Oracle database, for example. It's a drag and drop. Just provide some connection information, etc. So that's in the cloud. Then we also provide the Oracle Application Express, which I'm sure many on the call today are familiar with. It's a very popular tool for developing applications without much coding effort, mostly using SQL and PL SQL to the extent possible. And it also runs on the Oracle database, so it comes in a way kind of bundled, and it's really easy to deploy those applications on the Oracle database. So that same Oracle Application Express experience that you've had on-prem is now also available in the cloud in our database cloud service, right? So when you provision a database instance, it comes with Apex, and you can quickly go to the Apex console and start building applications, and it's already on the database. So it's really easy to build those simple applications. We also have a full-fledged developer cloud service, and it has all the bells and whistles that you would expect from a cloud service, including version control, for example, which is a similar experience to GitHub. You can manage your source code in the version control system. It provides all kinds of build automation tools, whatever your favorite tool is, Maven, Ant, Gradle, NPM, even command line. For continuous integration, we use Hudson there. There's issue tracking. So if you're using a collaborative multi-developer type environment, and you want to track your issues, assign issues to developers, understand how they are resolved, conduct code reviews between peers in a team, and then all sorts of deployment automation, either to a Java Cloud Service instance or to Node.js, as I just showed, just automatically deploying the code from the developer cloud service to any of these. And of course, agile process management, if agile is the flow that you use, plus wiki, etc. So it's a pretty complete service, has everything that a developer would need basically to kind of manage code and work with the applications.
Now, I've been digging into this a little bit. I like to play with all the new shiny stuff. One thing I wanted to bring up too is you're not locked into just this stack. So if you have a favorite, you can pick and choose and mix and match. That makes it kind of a really nice feature of this too.
Right. So we offer this in a couple of different ways. One is as a completely managed service, where it's a multi-tenant service, just like, for example, GitHub, right? You don't have to worry about what happens in the background. You connect to the service and you use it. And then we also want to offer it as a dedicated environment. So customers, as you said, they want to install their own, different build automation tool, different, CI tool. They can basically go ahead and do that.
Yeah, or even just, if you're big on GitHub, it even links directly to an external Git repository.
Yeah, correct. So yeah, you can definitely have external repositories show up in the list, and you can have multiple such repositories, those that exist within the developer cloud service and then those that are outside. Good point. Moving down the stack a little bit to the database, I just want to show what we have done in the database to kind of make it more appealing and useful for developers. And so, the Oracle database has been expanding to kind of accommodate different types of data types. And way back more than a decade ago, we started supporting XML, HTML in the database, and starting version 12c, which has been around for about four and a half years, we now support even JSON in the database. And so you could perhaps use an Oracle database as a document store. And the advantage there is that if you have applications that overall need a relational database, and for all the powers that a relational database provides, you might have other applications or parts of that application that would work better with JSON. And then the choice is, do you spin up a separate NoSQL database for JSON for that piece and then worry about how are you going to integrate the two? Or is it just easier to allow the Oracle database to kind of manage the JSON data? And many of our customers said, no, this would be good if the Oracle database supported JSON. That makes our life a lot easier. Everything exists in a single database in a single repository. So with that feedback, we started providing JSON in the database. And you have RESTful access to the database. Let's say you have a mobile application that kind of works with JSON. It can just talk directly to the Oracle database. And not to mention that the other problem people found with NoSQL databases is that once you put the data in there, accessing it, there's so much SQL expertise outside. And they were like, okay, I cannot use SQL to retrieve the data. Now I have to write some code. I'm not a seasoned programmer, or even for seasoned programmers, there's some time required to put something together to even query the database. And so one of the features that we wanted to provide was leverage your SQL skills and run SQL on JSON, just like you would on relational database, and extract data. So the Oracle 12c database, if you have JSON data sitting in there, you could basically write a SQL statement and it will fetch the JSON data just like relational data. And so customers just love that part, that they can continue to leverage their existing SQL skills. Also, as I said, REST is becoming very popular. And so we provide the Oracle REST data service that sits on the database and allows, whether it's a relational data or JSON data, to be accessed over REST. And so you could basically, as simple as, you have an Oracle database and you make in a browser, you basically make a REST call, or you provide a URL and it'll pop up the data. So whether it's an application that requires, that communicates over REST to the database, right? Just to kind of decouple the app and the database. Sometimes customers prefer that. Or if you have an internal application that you quickly want to expose and, just, hey, get the table data, but no SQL to write, just basically make a REST call or just type in this URL and you basically have the data in a table format. So all that is feasible with the REST data services.
Yeah, I wanted to jump in on ORDS is one of my new favorite things to do. I've been playing with a lot of, let me pop my camera back on here real quick, with a lot of this type of stuff. Let me turn it so. And so, I built something like this, and it's got the little chip that has the built-in Wi-Fi. If I want to get my data to the database, it used to be I'd have to stand up a whole new middle tier somewhere and load Node or Python or some REST service to connect to the database. But with ORDS, I can just set up the REST service directly on the database, and I don't have to load big fancy drivers on my little tiny chips. I just had to chip in. That's one of my new favorite things.
Yeah, no, it's cool. And the fact that the app and the database are so decoupled, you don't even have to you don't have to disclose information about where your database is, right? With the IP address, is it 1521, right? All of that is completely hidden. All the user has is the URL, and they're able to see the data.
Right, and there's a lot of really nice tools built into SQL Developer to, there's some wizards to just stand up REST services with ORDS really quickly.
Right. And then finally, I just wanted to kind of end your question with this slide here, is that DevOps is an important thing, and the number one thing that people want from is to kind of improve the developer productivity, and how much time they spend setting things up, running SQL against databases to kind of build a database, for example, or even provision a stack. And so one of the common problems that existed on-prem is that, let's say for a project, a developer needs his own database and application stack. It's a pain to go and talk to somebody and get it provisioned, and it can take days to weeks to get all that set up. And once it's set up, now the developer, it's his own. He has to go ahead and configure everything. Oh, I need a copy of the Oracle database. Where do I get it? I have to ask somebody to kind of create that for me. All of that was a long process, and so all of this takes time away from the developer. And what developers like to do is, write code, enable their business by doing that, get their job done really quickly. And so we've taken all that away, and not just we, but I think that's the power of the cloud. And what we wanted to do was take that a step further and kind of provide those kind of pipelines and the tooling around it in the cloud, so that taking an application from one state to another should be really, really easy. And a developer should be able to build a stack in his own space without overstepping on someone else's toes. And in a multi-developer setup, everybody has their own environment. Changes are made locally, and then they can integrate together. Integration tests can fire, so that entire pipeline, the agile pipeline, can be streamlined, and all of these artifacts can be easily managed and maintained. So this slide kind of highlights how an application, for example, would move from, say, state version 1.0 to 1.1, and I've shown different ways where you start by being able to clone a database, so you have your own copy of the database. You quickly instantiate an application server, pull code from the developer cloud service, drop it there, run it, make your changes, push the code, trigger a build, for example. All of that can be automated, and it really, really saves a lot of time for developers. So, I wanted to end here and see if you or anyone else has any questions on what we're doing for developers.
Excuse me. Yeah. Speaking of DevOps, that's my current focus. Is I'm really starting to dig in and learn DevOps. And like most people, I initially thought DevOps just meant build automation. But as I'm learning rapidly that it's much, much more than that. Specifically, what DevOps capabilities does some of the other cloud services provide inside of Oracle?
Can you elaborate on that question?
So you mentioned provisioning a new database. How do we automate some of these steps on your slide? I assume I've seen some of the REST APIs for, say, standing up a new compute instance. I haven't really got into that a whole lot. Can you tell us a little bit more about some of the automation features?
Sure. Yeah. And so again, remember, an on-prem ecosystem, if you look at it, there's many different areas, right? You have application servers, you have databases, you have code, and then all of these need to come together, right? So number one, you have to provide all of these different platform services that work with each other. And so Oracle's focus in the cloud is to provide value. We just don't want to provide plain infrastructure at a low cost and then ask developers and customers to kind of go do their own thing and deploy whatever they want. We do provide that, but I think the value is what can we do to take away a lot of those regular things that repeated tasks that you have to do, and provide the tooling around that, and allow you to focus on what you do best, which is build great applications for your business. And so, to give an example, the tooling to set up a database, for example, within 2 or 3 steps, you have a complete Oracle database set up within about 20 minutes. And let's say, for example, you want to deploy a production grade application, you would set up a rack cluster, which is a very popular technology for clustering and high availability. And anyone who has ever set up a rack on-prem knows that it's an involved process. It takes time. And so to be able to do that within a few clicks and about 20 minutes of time, it's simply amazing. And it just saves so much time. If you want to set up cross-site replication using data guard, right? One cluster running in region 1, another cluster running in region 2, having them replicate in real time synchronously. You can do all that, just the exact same way. Same 3 steps. You basically just pick a choice in a drop down and say, oh, give me data guard, for example. And you come back after a cup of coffee and you have the whole environment set up. So there's a lot of things that we do that save weeks to months for customers.
Oh, and as far as the developer cloud service tools that we looked at a little bit earlier, that's actually included with some of the cloud services that we have.
Oh yeah, I should have mentioned that. Yeah, so that the entitlement for developer cloud service comes at no cost to a customer. Whenever you subscribe to any Java cloud service or database cloud service, there's a few other services as well that it comes with. So it's kind of free for people to play around and deploy the applications.
And we also have the application container cloud service. So if you quickly build like a Java or a Node or a Python app, you don't technically have to stand up a whole compute instance and load Node or load Python. You can just deploy it directly to a pre-built application container. Can you tell us a little bit more about that one?
In fact, I can actually show you. So, I think we have done enough slides, and I think people would love to see what the real thing looks like. So if you don't mind, I'll jump into that and really show how the services work together. I put up a short demo so you can actually show what's on the slide, that, how do you take an application from one state to another? And, all of these different moving parts with, the database, the developer cloud service, as you said, the application container itself. How do you make all of these work together? And really, I want to show that as a developer, if I'm developing an application, this is what I can do. So do you mind if I can jump into it and show you what it is?
Yeah, that'd be great. I like demos better than slides anyway.
Awesome. Okay. So I have some windows open here just to kind of save us some time. And right, there you go. And so this is my dashboard. If you log on to, if you have Oracle, or subscribe to an Oracle Cloud service, you log in, this is what you see. Each of these styles is a different service, right? So as you can see, there's a variety of them for whatever you want to do. Of course, there's the database and app service, but that, if you're a MySQL user, that's MySQL right there. If you are a middleware person, and you deal with SOA, there's a SOA cloud service. Oracle application users trying to stitch, for example, different applications together, Process Cloud Service, SOA, messaging, for example, Integration Cloud Service. If you're setting up replication, Golden Gate, for example. So many different services out there, very, very complete ecosystem, very similar to what you would probably be doing on-prem. And so you pick any of the cloud services. Let's say I'm going to pick database here. You open your service console and you can see that all of the databases that you have, each of these is a database service. This could be a rack cluster. This could be a complex data guard setup that's replicating between 2 different instances. Each of these is a service. And the cool part is that, if each of these services, for example, are billed by the hour, right? Just typically how cloud providers bill, either the subscription price for a month or an hour. And so let's say if this is an hourly based system and I'm using it for test dev, I can actually turn it off. So, for example, I was working with this and I'm using 1 CPU and X amount of memory. I can turn it off and I'm not getting billed for it. That's the power of the cloud, is that, the cost is in your hand. Use it when you need it and turn it off and, turn the meter down. So what I'm going to show you is a demo where I'm going to take one of the applications that's deployed here. And this is running in our application container cloud service. This is a simulation, basically, right? So let's assume that there's a customer, there's someone, a gaming company that, well, not a gaming company, but a company that rents games online to its customers. And this is what it looks like. Customers, users come in, they sign up, So I'm just going to sign up here. And they browse for games, they like something, they pick it up, say, okay, I'm going to buy this. Okay, and then let's say they say, okay, give me this, and they go to the buy items page. And the situation is this, that the customer had just one store, and that store location was hard-coded in the application, right? So that's when companies started off really small, and they didn't think about expansion at the time. Now the business is doing good. They have stores in 5 different locations nationwide. And so the CIO comes in or CEO comes in and says, okay, we need to change the app. There should now be a drop down, right? So the customer can actually select what store it is from. So if he wants to walk into that store and go pick it up from there, they can do that as well. And so that's the change. Now, from an application standpoint, if you look at it, I have UI changes, of course. This needs to be a drop down. If there's a backend Java class that's handling some of the logic, then that needs to change. And then finally, from a database standpoint, if I want to kind of streamline this, if this was part of one table, now I need to have a second table called location, right, which has the seed data. All the locations are stored there. Then I'll have some sort of a referential integrity constraint that joins these 2 tables, for example, the product table and the location table, for example. And so all of these changes have to take place, and you can see that this is a reasonably complex change in the sense that there are 2 or 3 different tiers that are changing: UI, application, Java code changes, and the database change. And so what I wanted to demonstrate was that for a developer, how can you take this now? And I want to show this to you live, that I'm going to modify this app and I'm going to run it. I'm going to create my own database and all that. So how easy or how hard it is to kind of do that in the Oracle Cloud. And so let me show you what is the first thing I do as a developer? I'd say, give me the source code, right? Just give me the baseline code that I can take, and I'm going to modify, test it, and I'll make sure my modifications are right before I submit the code back to for example, a QA system, so you can test it out and see if this works there. And so I go to my dashboard. I go to Developer Cloud Service. While I'm doing this, if there's any piece that's not clear, or if you have questions, feel free to type them in your chat window, and then Blaine will pick it up, and I'll try and answer them as we go. And so in the Developer Cloud Service, my projects are set up. So you can see my Game Shop project is set up here, and all of my recent activities you can see here. I can see that my repository is a Git repository here, and this is where my code is. So all I do is basically copy this. And then I'm just going to download the code directly from there.
While you're downloading, I wanted to interject that when you create a new project in Developer Cloud Service, all of those tools that you see on the left are all provisioned for the project automatically. They're just there after you sign it up for each project.
Okay, I'm just going to drop the previous one because it would be an override, so I'm just going to clear this up. Okay, so I do a git clone and then get all of this down here. Awesome. So the first step, right, just get all the code, and then I'm going to look at the code and see what the changes are. And just to kind of simplify, I've pre-coded it, and so it becomes easy for me to show. Let's see. Oh, this is the one. This is file. Oh, recent. Just going to close this and reopen it. Okay. All right. So let's take a look at what the changes are. And what I've done is, what I want to show you is that without, number one, even getting into the database and trying to run SQL, I'm going to make the code changes, and I'm going to package the code so that the database and the application code can be version controlled together and also be deployed together. So as the app code gets deployed to the application server, the build also deploys the database code to the database server. So that's also a very desirable feature that developers have, is that how do I manage and maintain my database code similar to the application code, right? And not in a very separate data model of its own, where I don't know what's going on. If I look at an app, I cannot tell what state the database is in. So it would be nice to kind of package everything together, and this application does just that. So as you can see, when I first build it, my application is at version 1.1. You can see all of the initial build here. This is all the tables that I needed, right, to build the application. And then as I make changes to the database, I just put them on top of each other, and so different versions of it. So for example, now the location feature that we talked about has these changes, right? I have to create a new table called delivery locations, insert the seed data for it. As you can see, these are the 5 rows for the 5 new stores that are going to be opened, and then whatever else is needed. I'm creating a foreign key constraint with the order details table, for example. And then there was a PL SQL procedure that was used to update this table. So that has to change as well. So you can see that there's PL SQL changes, schema changes, all of that. And I've coded all of that in a SQL file that's going to get deployed with the database changes. That's number one. Number two, I'm going to need my own database. So I'm just making database changes. So let me just really quickly go and make a copy of the existing database and have my own copy. So that's something that you can really do quickly in the Oracle Cloud. So I'm going to go to the Database Cloud Service, which I'm running in this window here, right here. And then I have, for example, a multi-tenant database called GameShop Dev1, right? And as you can see, this is what it's running. It's running on a single OCPU. I go in there, I go to the DBAS monitor, which is a little console you have to kind of see what's going on with your database. There you go. I'm in, and I can see, not only I can see the status of my database, pretty much like a DBA view. I can see what's going on, how many alerts, how many sessions are open, any issues with the backups, all of that can be visible here. But what I'm interested right now is to manage the PDBs. And so pluggable database architecture, for those who is kind of a way of multi-tenanting an Oracle database, so that in a single Oracle instance, you can have multiple databases that are connected, and a really easy way for having multiple developers work on a project, consolidate applications, for example. And so I'm using that here because all of my seed data, for example, is in PDB1. And then every time a developer needs his own copy, all he needs to do is make a clone of it. So I'm just going to go ahead and say clone, and I'm going to say, let's call it ODTUG. And I'm also going to make a sparse clone, so it actually doesn't make a full copy. And this is a pretty cool feature that for practically any size of the PDB you have, when you make a sparse clone, it instantly makes a copy. It's a thin clone, and it doesn't take much time at all. So that's what I'm going to choose, because in the end, I'm probably, after I'm done testing, I'm going to throw it away. So I just want it quickly deployed, and so all I do is just provide the password for the encryption file, the encryption key, because everything in the Oracle Cloud is basically encrypted, and so it needs to make a copy. Let's make sure the password is right here.
I have a quick question here. Not being a DBA type person, when you say a sparse clone, does that mean you're not bringing over data, or what is included and what's not?
Sure. So a sparse clone is a thin clone, which means all the files, the data files, are not physically copied from one place to another, but rather there are pointers generated that point to the source But at the same time, if you make changes to the database, they are saved separately. So from a developer standpoint, you can mess with it, you can do whatever you want, and as many changes, and those are stored separately. But the reads are directed to the source, basically. So you have this. Every developer has the same experience in terms of the database, and not to mention that it clones really quickly because it's not actually copying all the data. And so you saw that I just cloned within a few seconds while we were talking. I have my own copy of the database now. So this is what my copy is, and this is what I need to connect to. Did that answer your question?
Yeah, now I'm curious. I got to go play with that.
It's a very cool feature, and I cannot emphasize enough that this is a real world scenario, right? This PDB1 could have been half a terabyte or a terabyte, and it would still take as much time to clone it, which is a significant thing. Okay, so I'm in my code here. I have my own database copy. Let's see. So what are the other changes that I have to make? So in the front end, I have to make a UI change. And to keep it simple, what I have done is made the changes in a separate file so we don't have to all start coding Java and JavaScript here. WebINF, no. Right, so there were two files that needed change. The Java class is coded here. So what I've done is, this is the code that's in there right now. The new changes are in this file called pyitems.java.news. I'm just going to rename the file so you have the new code now. So let's call this the old one. And this will put this one as a current byitems.java. So I did that. Then the product changes over and the UI changes. They're in the web app folder. And this is the one. So the JSP page, basically, right? So this is the old one. So I'm just going to rename that to old. And put this one in its place. Okay. So I did the front-end changes. I did the Java changes. Let's go back and look at the SQL once again, how we get the SQL in there as well. Right. So my location feature, this is what the SQL is, right, as we discussed. And so all I have to do now is once I finish coding this, right, I write this down, and I would basically just rename this file and call it version 1.2, which gets layered on. So v_1.2. That's it. And so the build will automatically know that the database is at version 1.1, and it will basically say, okay, I have to take it to version 1.2, so it'll migrate that to 1.2. And I basically use an open source tool for that called FlyAwayDB, and it's a pretty cool tool to version control and manage your databases. If you haven't tried out, you should try it out. So there you go. I have all of my changes in place. I am going to, I missed one thing, but I guess it's going to be okay. I would typically first branch out, right? That's how you would want to develop. You just create a branch and then do it in a separate branch. But in this case, I think let's say that we did good on the main branch. That's fine. I'm going to say add these files to my repository. Let's call it location feature. Just added the location feature. And okay, I have changed 2 files, made 2 insertions, 1 deletion. Okay, let's see. I hope I'm in the right folder here. No, I'm not. So this is where I should have been. There you go. Okay, so then I say changes are committed. Let's build and see what happens. Oh, hold on a second. Before I build, I have to now point my build to the clone that I created, because now I have my own database. So I'm going to go back to Sublime, going to go to build.sh, and it's on the same IP. And so all I have to do is basically just change the name of this database here to ODTUG. Yeah, right here. Okay, so does this all make sense, Blaine? Just want to get your feedback. Hopefully others would get it equally. That all I'm basically doing is I'm trying to build this app locally to see, is my application working as I'm expecting it to. I made the code changes, but then my database is running in the cloud. So all I have to do is, as you saw, I just made a copy of the PDB, and then I'm pointing my app to use that particular copy, right? So let's see. Let's hope we got the name right here. What was it? ODTUG. Okay, good. So we got that right. I save it. I'm going to go ahead and build it. And you can see it right there, my database migration. So we first built the application, compiled everything, and then finally it's migrating the database. So you can see that it took it to the next version. There's currently the version of the schema is 1.1. I'm going to take it to 1.2 because I see that you've added that feature there, and it successfully applied that migration to it. So that's it. That's all it takes. And so I don't even have to connect to the database. It's auto-deployed now. And all I have to do is run my app and see whether the changes took effect. Okay, should be running now. Let's check localhost and see if it came up. Okay, so running on localhost. Let's register. See. Register a new user. Go back, try to buy something, Grand Theft Auto. And oh, there you go. Okay, so you can see that my store location is now a dropdown. So I'm pretty certain that, okay, everything worked fine, looks good. Locally, this is all on my laptop and it's running locally. I'm running a local app server here. And so now I'm ready to push my changes, right? So the next thing I do is say, okay, I'm going to go ahead and push these changes to the cloud. I've already added to my Git repo, so I say git push origin master. All right, I pushed it. So let's.
Just to clarify, that pushed it back to your developer cloud services Git repository.
That's right. So remember, we first downloaded the original source code from the developer cloud service, right? Then we modified it locally. We tested it locally, connected it to a cloud database to make sure that everything's working. So now changes are working locally. Let's go ahead and build this in the cloud and see how that works in the cloud as well. And I'm going to need my own app server to do that as well. So we'll see how we get that. And so
I'm not familiar with Git. Think of it as having two separate version control repositories that work together, so you can do all your stuff local, and when it's good, then you push it up to the shared one with everybody else.
Right. Right. And this could, I mean, we took a simple example here in a way, but this could be a much more complex change with, more than one database, more than one table change, and other developers have their own pieces of code that they, so they would each test it locally, make sure it's okay. They push it, as I said, they would probably branch it so you could test the branch, but eventually, it all gets to the single repository where you can run each of those builds and see which particular build kind of fails for any reason, and then that way catch the issues early on and be able to pinpoint what developers changes made those issues. So it just becomes more easier to pinpoint issues, and this is how things work in the Agile world. So let's go back to the developer cloud service. There you are. This is where we got it from. Let's make sure. I'm going to refresh this. Okay, so you just saw that I just pushed those changes and they're in the master repository. I'm going to go to my build and take my QA build. And then I'm going to build it again, right, with the new code now. So the code has changed here. So build. By the way, I could have set this up so that this build automatically triggers as soon as I push it, right? So it allows you to do that. If you go to the build configuration, and just going to show you a little bit of this. So the source code for this comes from the gameshop.git repository from the master branch. And I haven't set up any triggers, but you could say that, set this up on SCM polling schedule. So it'll keep polling the source code management system. And as soon as it detects a change there, the build will fire. So if you're gonna, if you are in an automated mode, as soon as you push the, even in the middle of the night, you push a change, it picks it up and it will basically start building. And so the build has just begun. And this, as I said, is a shared environment. So this is a fully managed service where multiple tenants exist in in a completely secure fashion, just like GitHub. If you're used to using GitHub or any of those external repository services.
If you're like me and you like to watch what's going on too, you can click that little icon under the console column there and watch the console responses while it builds.
Exactly. Right. You can see your console. You can see what's going on. It first clones the repository, downloads all the dependencies, and deploys it. How are we doing on time, Blaine?
We have about 12 minutes.
Okay. So while this is building, let me just show what I can do on the other side, right? So I want to now deploy this code. Once it's done, I'm going to deploy it. So to deploy it, I would need, let's say I need my own app server. So that's also pretty easy to get. You could basically just say new configuration and get your own application server and deploy this code there and run it. So I have two of these going on, and if I want to have a third one, I could have just done that. So as I said, this is a Docker-based container service. It can create an app server and deploy an app within a few seconds. But I'll wait for this build to complete. Hopefully everything goes right and it builds successfully. Then I'm going to go ahead and show you how to deploy this and then test that your application is working fine in QA as well.
And if you want to go towards a full continuous deployment type model, if you're brave, I don't really like to do that with any tools, but if you want to do that, you can add that in as an option for this build. So you run your build, you do all your tests pass. At the end, you can have this the build that's running deploy automatically.
Deployed. Right, that's true. Yeah, the build fired. So basically, what happens is that you make code changes, you push the code to the repository, build automatically kicks off. As soon as the build completes, deploy kicks off the changes in.
Okay, we have a question while this is running. What happens if you have multiple clones providing builds at the same time?
You could basically have different jobs running. You could do that too, or the builds will get queued up, right? So, for example, let's say you're using the same build for that code base. So, as you know, so number one, typically what will happen is that you'll create a branch, right, in your local Git, and then you'll push the branch. And when you push the branch, your multiple such branches get pushed by many developers. Let's put it that way. And then you would probably have some sort of a review process to say, someone says, oh, I'm going to review this code, and then I'm going to merge it. If that's the case, then you're going to merge it, you're going to run the build. You're going to merge it, you're going to run the build. And you can see which particular merge failed the build if that happens, and you can catch the issues. If the setup is the way it is now, right, I just pushed directly to a master branch, for example. You could do that too, and it can automatically trigger a build. And you could have a separate build of your own. You could just say, I'm going to create a new build. By the way, our build is successfully completed here. Right, so I'm going to say build, and I'm going to say new job. Okay, and I'm going to say copy an existing job. So I could have taken this thing, oh, give me a copy of the QA job. I'm going to call it my own, right? And so you can have your own build, and you can test it as many times as you want. So this completed. Let's go ahead. This was build number 16. Okay, so I'm going to my deploy. Then I'm going to deploy to the same server just to keep it easy. But you know, I can deploy it to a new server as well. It's asked. Let me just show you that. I'm going to call it my QA or ODTUG QA. Okay. I'm going to say deployment target is my account, and test the connection to make sure everything is okay. Yes, it was able to connect. Use this connection. It's a Java application, and it's billed hourly. And pick up this particular job called Game Shop QA, and build number 16, which is successful. That's what you want to deploy. This is the artifact that it generated. That's it. Just say save and deploy. And it's basically going to provision a new application server and then deploy this build to that server.
While that's going on, I had scrolled my window too far, so I missed a question a little bit earlier. Going back to sparse clones, and the question is, so a sparse clone shares disk blocks with the source for reads. What kind of performance hit does that cause on the source database? And can I see the performance hit is caused by a clone when monitoring the source?
Good question. If you think that you're going to really hit, going to make a huge read, then you got to watch it, number one. Number two, you're not going to take a production application and make sparse clone out of it and start using that. You're probably going to have a test master, right? So the typical practice is, let's say you want production data, and that's what your developers want. You would first take the production database, make a test master out of it. You can make a full clone out of it, right? So this will not be a thin clone. You make a full clone out of it, and there's ways to automate and do that as well. I could probably show you in a little bit if you have time. But you could make a full copy of the database, either PDB or even a complete container. You could say the entire CDB, or if it's 11G database, a standalone instance, you want to make a full copy, you could do that. Once you make a copy, then you make all these sparse clones out of it, right? And so it's the test master that's taking the hit. And so for most development instances, I mean, workload is spread. You have 5 developers working at different times, and so you have to manage that. But yes, if you're going to have heavy reads, all of those reads are going to go against the source database. There you go. We just created an app server and deployed it, and so I'm going to just go and test and see everything works okay. ODTUG QA. Okay. Same thing. Yes. So my change was successful. Okay. I'm happy this worked out. Okay, so that's how simple it is. And we did a lot. There were a lot of moving parts here. And so we did that in about, what, 30 to 35 minutes, except for the actual coding, right? So I mean, if you see, this is where it saves time. This is where you're going to spend most of your time actually writing the code and very little time doing all of this, right? So in a really short period of time, we were able to get a copy of our own database, create our own application server, build it locally, push it to the cloud, use the cloud build tools, all of that, and get our change going. So I hope this was able to kind of demonstrate what a cloud service can bring to the table for you.
And the more you follow that process, and the more you'll start adding more automation to the individual steps, and so it kind of snowballs to the faster angle. So the more you use the tools and add to them, the faster all of this goes, and the more you get done.
Right. Right. So we have about 4 minutes. Do you see any more questions, or maybe you can even open up the chat line for questions? I guess that's already open. Maybe the voice line, if you do that.
I don't see any more questions yet. Does anybody have any more questions? I would like to touch on one thing that you talked about there a little bit. You mentioned Flyway DB for database schema migration. I think having a schema migration tool is almost critical at this point in developing modern applications, and there are a few out there. Flyway's next on my list to go learn. I'll probably be doing that next week. I've looked at another one called Liquibase. That's a great one. I've looked at, if you've ever done Ruby development, they have Active Record has a built-in migration tool. Python, I'm not sure how you pronounce the name, Django or Django. It has a migration. But if anybody's curious on that, just go search for database schema migration and pick a tool and try it, because that's it's a very important step in making sure that your code syncs up with your database rather than just random SQL scripts.
Good point. The thing I like about Flyway myself, by the way, is number one, you saw the simplicity with which I could install it. And most of the shops have, let's say you use a data model tool that generates all your SQL, right? So you go to the modeler and say, I'm going to add these tables. He'll add that, or you add it yourself. You generate the scripts. Now you have your SQL scripts, and that's what you know best. And so just taking that SQL script and dropping it here, right? And basically giving it a version. That's all it takes. And then from a deployment standpoint, let me just show you that one line that I have in here in my build, right here. I'm using Maven here, so I'm just calling Flyway as a goal and say migrate. That's it. Give it the database IP and the name of the PDB here, username, password. That's it. This is all it takes. You don't have to install Flyway anywhere. I didn't go and put it in the database instance. No, nothing. Just basically, on the fly, you're able to get it downloaded. So Maven would download the Flyway module and run it. And so that simplicity and the fact that you need to know anything new, no new tricks to learn. Use SQL, and as I said, most shops do basically use some sort of modeling tool to keep the data model and then generate SQL out of that, and you can basically just layer this on top of each other. That's what I like most.
And it keeps track of what has been run in the past, so you don't have to go back and delete the old version 1.1 or anything. It knows that.
And as a best practice, as you see, I also have a rollback. So I wrote the location feature, and I wrote a rollback.sql. Let's say something went wrong with this. All I had to do was, in production things don't work. I need to go back. I'll call this 1.3, run it, and my database is back to where it was. So just layering SQL on top of each other and moving it forward is how it works. Okay, we are close to the top of the hour. Any other questions?
I'm not seeing any questions.
Okay, back to you, Karen.
All right. Well, thank you both, gentlemen, for being here today, and thank you all for attending. Again, the recorded webinar will be on the ODTUG Code Talk page of the ODTUG website, and have a good day.
Thank you.
Thanks, everybody.